So when I was talking about geometry and all the different little patterns that interplay with them, here's an example of what I was doing. I created a pentagram here, and here was the golden mean, and just all of the construction lines that developed as I was building these constructions. I then started to create some patterns with watercolor, using watercolor that is translucent, so achieving different colors from just a yellow, a red, and a blue, and ending up with some greens and some oranges and that sort of thing. But all of these patterns that were regular in just how I ended up constructing these pieces of geometry. So my next favorite is the golden mean. And having watched Donald Duck in Magic Land, you have a good sense of why this proportion is so important to us. And another book that I adore, and just because this proportion is just so fascinating, and so I think get to know it and get to recognize it. And as I said, you don't have to make up dimensions. If you just use these inherent natural proportions, your designs will end up being really quite lovely. So I'm going to build that golden mean, but I'm going off in this direction, and I'm going to use this as my basis. So let's just establish a bit of a pattern. We said that we would take the same distance away. So I will just draw another diagonal, and as soon as that diagonal comes across, or this horizontal line comes across, I now know that that's the precise half distance away from that square. And with a golden mean proportion, you do start off with a square. So let's just build off these horizontal lines, just make them a little bit longer so that when I draw my diagonal, like so, to create that square, going to double check I've got that correct. There we go there. So a golden mean rectangle starts off with a square, like so. So let's call this now proportion side 1. That's its distance right there. From this, we need to bisect a line such that we can get our compass point. We're going to end up creating an arc that comes down here. So in other words, we're going to start off with that square. We're going to bisect it as we already have. There's my bisecting point. I'll put my compass point here. I'll put my pencil lead here, and I'll draw a beautiful arc that comes down here. And from there, what I end up doing is extending that line, and as soon as it hits that arc, that becomes the magic proportion for the golden mean. So it's really a simple construction. So bisecting this line, and from that, I now have a place to put my compass point. And I'm going to just extend this line because eventually I'll need that arc to intersect that line there. So taking my compass and putting it precisely on that point, now extending it until it reaches this corner of this square. So right there. And this is one that you do want to be precise on because it'll show up as you build more of these, decrease the size of them. So right now, that is extending, becomes my golden mean rectangle. So why is it called golden? Well, you had a little bit of a sense of it, of how often we see this particular proportionate relationship in nature. And it's not a matter of 2 to 3 or 3 to 4. It's actually closer to 5 to 8. And I'll show you why. That always, if this side is 1, or even if it's any number, it could be 20. If I multiply it by 1.618, I will get this dimension. So we'll understand why that's important in just a second. So these construction lines are really important. Let me just show you what happens. This is the really interesting part of this, is that when I draw a diagonal line from one corner to the other, so this corner here, and I hit the original square line, I'll just make a little mark on it, what happens automatically at this point is I achieve a square. So I have a square and yet another square. And this is a golden mean rectangle that's left over. And this is a golden mean rectangle right here. And this is a golden mean rectangle. And it can go on and on and on. And I'm going to draw one more diagonal at that corner. And where it hit on this line if I draw a vertical line, guess what happens? I end up with yet another square, with yet another golden mean rectangle, and you can see that diagonal line hit on this golden mean rectangle here, and I can just continue to go on and on and on, and that's exactly where I get my square again, and again, and again, and again. And so much fun that when I take my compass, I can now create an absolutely beautiful nautilus curve, and I'll just draw that quarter turn here. There's my quarter turn from one point to the next. And I just keep reducing it and creating more quarter turns in one square, and then make it for the next square. So it goes up there. Here's my other square, and this is why it's really key to be precise from the get-go when you start to build these things, just so that everything lines up gorgeous. And that becomes, oops, my other part of my spiral. And had I taken a little bit more time, it would have been much more precise. And yet another quarter turn, and another quarter turn, and you can start to see what's happening. And I do need to adjust my compass lead because I'm starting to lose it. But really nice nautilus curve that has developed, and you can go on and on and on and on and on. So there you go there. And from that little exercise before, and just as I say, all of these construction lines really do add to the beauty of that. So going back to this, and what's so cool about it is it's called the Fibonacci series of numbers, and I'm sure you've heard about these before, but if you take 1 and add it to itself, you get 2. And you add those two together, you'll get 3. Add those two together, you'll get 5. Add those two together, you'll get 8. And so on and so forth, all the way down the line. What happens eventually when these numbers start to get a little bit larger, they divide such that if I divided this number into that number, it equals 1.618 all the time. And that's why these two numbers, or even these two numbers, and sometimes even these two numbers, have a pretty close approximation to a golden mean rectangle.